Now we go to the second example. Okay, so this example actually we are referring to the first example. Okay, in our first section in this chapter. Okay, so this is example 1. Okay, so in this example 1, we assume that lambda equals to 24 and mu equals to 30 customers per hour. Okay, and in this example, we calculate all the characteristic, okay, all the P0, L, LAQ, W, WQ. Okay, so from this first example, we have W equals to 0.1677 hours and WQ equals to 0.1333 hours. So if we convert into minutes, for this one, it will be roughly around 10 minutes. And for the WQ, roughly around 8 minutes. So now back to our example. Okay, so from the calculation, W equals to 10 minutes and WQ equals to 8 minutes. Okay, so basically we have already changed or convert from hours into minutes. Okay, so now W here is the average waiting time in the system, and WQ here is the average waiting time in the queue. Okay, so now the stores manager believes that it is unacceptable for a customer to wait 8 minutes and spend a total of 10 minutes in the queuing system. Okay, and these 8 minutes and 10 minutes is not including the actual shopping time. So now the manager wants to test several alternatives to reduce the customer waiting time. So the first alternative is by adding or hiring another employee, okay, in order to pack up the purchases. Means that add or hire another employee and ask him or her to do the packing. Okay. Remember, when you're at the counter, sometimes you only have one cashier, but sometimes you have one cashier and one assistant. Okay. The assistant will assist the cashier by packing the item. So in this case, the service would be better, and it is easier for the customer. Now, for the first option or the first alternative, we want to hire new employee. So when you want to hire a new employee, so basically it will involve some cost. Okay, so the cost is 150. Okay, 150 per week if you want to hire another employee. Okay, and then cost of lost sales is 75. This is actually the cost because we want to avoid loss of call sales. So just imagine, okay, if you have a very long queue, okay, and then suddenly some of the customers don't want to remain in the queue, so they just go out from the system. Okay, so in this case, you will also, for the business, you will lose the customer. Okay, so we want to avoid that. So for each minute, the waiting time is reduced. So the store will avoid the cost of lost sales, and the value is 75. Okay, means that kalau originally you ada 8 minutes in the queue, kalau you reduce to 7 minutes, so 1 minute equivalent to 75. So you dah jimat. Okay, you already saved 75. Okay, so let me just play more. So this is the counter. So assuming that we have only one counter, so we are using the single server queue model. Okay, and this is the queue. So originally we only have one person here. Okay, and this is the cashier who will serve the queue. Okay, the counter. Okay, the company want to hire a new employee, and he or she will have to pack or will be the cashier's assistant. Okay, so in this case, the arrival rate is still the same. Okay, we still consider lambda equals to 24 per hour, but now for the service rate, since we have somebody who assists at the counter, okay, so now we can assume that the new service rate will be 40 per hour. So normally in the exam, this one will be given. Okay, so you don't have to worry. So this one is just for the demo. Okay, so now instead of 30, originally it is 30. Okay, for the service rate. So now service rate already increased to 40 per hour. Means that in 1 hour, before this, in 1 hour you can only serve 30 customers. Now in 1 hour you manage to serve 40 customers. Okay, so now we can calculate WQ. So WQ for the single server model is lambda divided by mu times mu minus lambda. So substitute into the formula. So you have 0.0375 hours, and this is equivalent to 2.25 minutes. So we can compare before this. Okay, WQ, the value of WQ is 8 minutes, but after we hire another employee, okay, to help the cashier, now the WQ, okay, or the average time to wait in the queue is 2.25 minutes. So in terms of the saving, so originally the customer have to wait 8 minutes in the queue. So now they only have to wait 2.25 minutes. Okay, so the difference is 5.75 minutes. Okay, and remember the cost of lost sale, okay, that we want to avoid. So for every customer, the cost of lost sale is 75. So now you have 5.75 minutes that you save times with 75. So we have 431.25. This is the one that you managed to save after we reduce the WQ. Okay, after we reduce the average waiting time in the queue. Okay, so you can save 431.25. But you have to remember, since you hire another employee, so you have to pay for the salary. Okay, so in this case, when you pay for the extra employee, okay, before this you can save 431.25, but you have to pay another 150. So we have a balance of 281.25 per week. Okay, so basically we can save 281.25 for that particular week. So when we compare the first alternative and the original condition, so obviously the first alternative is better because we can save 200 something. Okay, now we go to the second alternative. So for the second alternative, we try to add another checkout counter. So for this case, I would like to divide this into two options. Okay, so okay, option 1 and option 2. Okay, still the same. Okay, we want to add another counter, okay, additional counter, but this one, okay, the first option is like this. So let's say you have, this is your original queue, okay, and this is your counter. So now when we add another counter, okay, so we assume that the queue here will be split into two, and some of the customer will be here. This one, how much you go to the CMart or to the Tesco. So we can see that if let's say we have 5 counters open, so we also have 5 queues there. So that is it's like this. So in this case, I just have 2 server or 2 counters and 2 queues. So this is not the multiple server, this is actually a single server, but we have 2 single server, the first single server and the second single server. And the second option is okay, you have the original queue, okay, and then you open another counter and the queue remain the same. Means that we still have one queue and we have two counters. Okay, so this is multiple server. Okay, this one single server. So let's focus on this one first. Okay, the first alternative. Okay, the first option for the second alternative, where we add another counter, but now the arrival rate will be different. Okay, so if let's say you want to add another counter, okay, additional checkout counter, so it will involve some cost. Okay, so let's say the cost for the renovation, okay, is 6,000, and of course after you add another counter, you must hire a new cashier, okay, to work at the counter. So the cost for the cashier is, let's say, 200 per week. Okay, so these are the costs that will involve. And then tadi I kata you add one counter, sorry, this is the original counter, okay, and then you add another counter, but now we assume that half of this will come to another counter. So in this case, our original lambda or the arrival rate before this 24 per hour, so now it will be reduced. So our new lambda will be, kita assume, will be half. Okay, half from the original lambda, so it will be 12 per hour. But for the service rate, it remains the same. So one cashier can serve 30 customers in 1 hour. So we reduce this new parameter. Okay, lambda equals to 12 and mu equals to 30. Okay, so calculate WQ. Again, the formula is lambda divided by mu times mu minus lambda. So substitute the value. So you have WQ equals to 0.0222 hour. And when we want to convert into minutes, it will be 1.33 minutes. So when we want to calculate the saving, remember the original WQ, okay, is 8 minutes, and now we can reduce to 1.33 minutes. So we calculate the saving here. So original we have 8 minutes, and then we can save up to 1.33 minutes. Okay, WQ is 1.33 minutes, so we can save 6.67 minutes. So for every minutes that we save, the cost is 75. Okay, the value is 75. So basically, we can save 500.25 per week. Okay, but remember, this is only, we just consider the WQ, okay, the value for the WQ. So since you hire another cashier, so of course you have to pay for the salary. So when you pay for another cashier, okay, so now your saving will be, so you minus 200 because 200 is the cost for the cashier. So now your saving is 300.25. So you can save 300.25 per week if you add another cashier and using the single server model.